Hello everybody, and welcome back to the fifth part of this tutorial series. Today we'll be covering memory, and I would say this is going to be kind of a quick one. Basically with memory, not that one, but you can have four channels to work with, just like I covered in the overview. And memory is very useful. You can put whole blocks of signals into here or whatever, and then you can move the whole thing with commands such as xmove right into your output buffer, and just send out entire packets of signals all at one time, which can be very useful at I'll explore later on in I think the multiplexer example after this tutorial. Actually, let's leave this open for now. Oh, should turn on alt mode too. Okay, so first thing I'm going to go through is just the very basics here. So values in your registers can be moved into memory, so I'm just going to create a little basic value here. And so we have just like if I have iron and R1, and you can move things directly from the register into the memory, as you can see. You can also load values directly into memory, so you can create them right there on the fly, right on the spot, instead of having to load it into registers. So basically, I just want to show that when you're doing calculations and stuff into your registers, your typical control flow is going to be where, just like before, all your computations and stuff take place with registers, and then you just stuff things into memory or pull them out of memory and then work with them again. You can't add, subtract, or whatever two memory cells together and then push them into memory or into the register. Just remember that. Okay, so just going to go through this basic example. You can directly load something into memory, so you can write basically directly into your memory as well. It's making a funky little combinator noise. And also directly from inputs. So I have a, I think I'm going to be doing on the red wire this time first. So yeah, I have a little memory cell here, E with a value 1, and I'm just going to load that as well. So you just say FIR M3, where you're going to put it to, and you just look for your signal type that you're looking for, and I'll load it right in. Yeah, like I said, this is going to be on the short side. Anyways, and you can directly load an entire wire. I think I've already shown this with the xmove command. I'm not 100. Yeah, okay. Yeah, the previous one little snippet video that I had, you can in fact load everything on a single wire. In this case, I'm going to be doing everything on the green wire, which is just 4 signals here, and load that into memory 2, as you can see with the xmov command here. Now, here's some of the little constraints here of what you can't do. Destination has to be a register. It can't, yeah, when you're doing any kind of computation, like I said before. What you can do is you can, oh, shoot, okay, I was like, this kind of looks like code. Hold on a second. Let me just, okay, so what I'm going to do here is just have like a little example of what will happen if you try and do a operation. Like I said before, you can't do an operation loaded directly into memory. Everything that you do takes place in the register world. So I'm going to do a adding a memory address to a register here, which you can do that. That's totally fine. But storing directly into memory after messing around with your registers is going to throw an error. Yeah, I kind of figured that was going to happen. Yeah, so it says line 21 register expected. So as you can see, this is a register. So yeah, the register it's referring to is the destination. Yeah, just remember that you can't, when you're doing a computation, you don't save directly into memory. So you can, like I'm going to show, first I'm going to have to just comment that out without the P. Right there, establish a breakpoint, go back. And so yeah, you can compute with a register and a memory address. You can compute with these two just like you saw before, but it has to be saved to a register. You can't mess around between these two different things and then save to the memory address because it's kind of like a cache. As a storage unit mainly, it's not something you can compute with. That's what your registers are for. So as you're going to see here real quick, I just said, add R1 to M1, right? And then store it into, right there, into R1. All right, so continue with this quick little tutorial. So you can also move your single values. In this case, I'm going to show you moving a single value from memory 1 into the output. So this is going to be it's kind of interesting because, like you might have seen before in the overview and other times, there's 3 little output buffers here. So now we're going to cover that in detail. So output scalar is for individual things. So if you say move an individual value, it could be something like this. It could be a predefined value like move out, and you could have like a compound, something like this. By the way, if you want to define what's in a register, you just right click and it'll just tell you what's in there. And if you want the register itself, you just left click. So left click for the address, right click for the value in the address when you're doing that with your registers. Okie dokie. So I'm going to take this guy here, 2, and just keep that as a little example here to show you as well. So first I'm going to go and move the what's in M1 right here, this 5 steel, into the output. What the hell? Okay, so apparently we have discovered a bug in this tutorial with fCPU currently. So I guess when you try and add a memory address to a register directly and then save it to a register, it totally screws it up. Because right now the value of R1 and M1 are both the same. Maybe that has something to do with it. Maybe it just has to do with the fact that adding a memory address and a register and then storing into a register screws it up. But as you can see, we don't get 10 steel here. We get 6 steel. And worse than that, when you try and move what is in the memory address itself, which as you can see, it still says 5 steel. When you try and move this thing out now, it's actually going to freak out, and instead of outputting the 5 steel, it's going to like jump 2 places and output the E signal in the 3rd memory place, which is really friggin' weird, as you can see. So, really bizarre. Right, so I said M1 in the 1st memory slot, which is supposed to be the steel, not the 3rd. So that's going to be a bit of a bug to fix. Definitely. Anyways, so yeah, I'm just going to move like this value here, which is the 6 steel. It's supposed to go out. Actually, you know what? I'm going to say R1 and test this here as well and see what we get. Okay, so when you move the register, okay, so the register doesn't get, only the computation gets effed up along with the memory. So this apparently it'll screw up where the memory address is pointing to, M1, apparently points to M3. And but the register itself doesn't get screwed up after it's saved too. It just still, it outputs what it's supposed to output. What in the F? So now what I'm going to do here, just as a little test, is I'm going to also just check out move to output 3, M1 in place 3. So now I'm going to say move this out. Jesus. And as you can see, okay, weird. So apparently M3 is now 5 steel, even though it says So these got swapped somehow. So apparently this swapped the places of memory. The place 1 and place 3 just got swapped out. What in the F? Okay. Well, that's weird. All right, so whatever you do, don't screw around with your memory and registers. Always import memory into a register first before screwing around with it. So remember, kids, don't mix registers and memory. Just like water and electricity, don't mix them together. What the okay, well, that's new. Yeah. So don't do that. Jesus Christ. Okay, so let's see here in the output vector. What I'm going to do now is I'm just going to take everything memory 1 here, and I'll preserve the positions, by the way. So this will be, when I move this to the output, this will be output 1, output 2, output 3. Jesus. Actually, hold on a sec. Good thing that, oh no, the instruction pointer does. Ooh. Okay, so what I'm going to do now is I'm just going to clear the output buffer first, because I did not anticipate this shit happening. Okie dokie. So now I'm just going to clear the outputs. Okay, period. And now I'm going to move the memory here. Okay, so move all this and see if it swaps it. It does. Jesus Christ. Okay, so yeah, things break just a little bit when you mix your registers and memory together. So remember, if you want to screw around with something in your memory, if you want to operate on that, what's in your memory with your normal commands, Jesus, what you have to do first is don't do this. What you should do is you should first move your M1 into, like, say, register 2. Move this into register 2 first, and then add R1 and R2, not directly adding R1 and M1. Jesus Christ. Okay, well, that was new. Yeah. So, anyways, let's continue to indirect addressing. God. Oh my Lord. I just want to see here if. Okay, so technically these registers are all fine. Let me clear the friggin' output buffer just in case, so I can exercise whatever the hell's going on here. Okay, so this is had a full bona fide certified exorcism done on it, so it doesn't continue screwing things up. Oh shit! You know what? I should also just clear the friggin'. Hold on. I'm just going to go back, wipe out this Borkism right here, because this is actually 5 steel and this is 1E. Jesus. Hold on. I'm going to pause this and we're going to I'm going to un-F this situation here. Hold on. Okay. Well, it's still broken. I even copied the script. You know, I commented these out. Deleted this thing, replaced it, pasted the script back in, and it still reverses the order of what's in the memory. I don't know what the hell is going on. Maybe it reads it from right to left. I don't know. Oh, by the way, with the scalars and stuff here, that's just because one of these, out 2 is just register 1. But when I output stuff here from the via vector, it actually reversed the order for some reason. I have no idea what the hell's going on with that. Okay, so that's weird. Anyways, let's just continue on with the thing as it is. Let me see. What the fuck? Okay, you just saw that right before your very eyes, folks. Why? I'm just gonna wipe the sucker out. Just gonna clean the sucker out. Okay. Anyways, so the memory channels are still there. These have not been modified like you saw before because I got rid of the statements that mix the two together. These have been ignored. They've been commented out. Yeah, I have no idea. So, anyways, moving on. Indirect addressing is very useful when things work. So indirect addressing is pretty neat because what you can do is just like you saw in the previous tutorial on conditionals when I was showing you the LEA command and stuff. It's kind of like that. So what happens here is instead of giving the direct address of something, so say instead of saying the third place in the first memory channel when that actually works, apparently. What's going to happen here is that you get the signal in M1 that R3 points to. So that's why I just moved 1 into register 3. So what's going to happen now is it's going to say move the signal that register 3 is pointing to in M1. In this case, it's going to be 1. So M1 of 1, hopefully. Take that and move it into R2. God help us, it actually worked. Okay, so that's how this thing normally works. Why did you just skip? Pure evil is happening, folks. Okay, so let's see. Move right into register 2. What the? Okay, dokie. Alright, so let's see what happens here. This thing's broke as all hell. Okay, so apparently the something is going on with fCPU here. The tutorial that I ran through before worked well. I guess when I screwed around with this, something went totally haywire. I have no idea. Maybe I gotta reload the save. Let me try doing that. Okay, yeah, it's still broken. Weird. So anyways, this thing worked before. I have no idea what the hell I did. Yeah, so I'd reload the save. It's still weird. Maybe it's because the first thing I imported, even though it was on the red wire, was the E. Yeah, I mean, this was M3, which I had directly loaded into... Okay, I think it has something to do with this, because I loaded E into this wire right here. Yeah, these were created in-house. This was created via... This was imported directly. And apparently, when you import directly, takes precedent over whatever else. I have no idea what the hell just happened. What's going on with this thing. Let me know if you find out. I'll leave the script and blueprints here. I always put this stuff on Factorio prints so you guys can hopefully learn from it. But in this case, I guess it's a troubleshooting challenge. So let me know if you find it out after the end of this video. Weird as can be. So here's another little thing you can do. It's this is what shows up first, unfortunately, under indirect addressing, and this is what confused the living hell out of me when I first saw it, because it's a register of a register right here. So instead of it pointing to, instead of a register R3 pointing to a position in M1, it's a register in it's a register from that R3 points to. So in this case, R3 has a value of 1 still. So R3 is going to be pointing, in this case, to R1. So this is kind of a weird, wonky function you can do. I don't know why you would do this, but, you know, whenever your creativity desires, you can do this. For you're pointing one register to another register. I mean, you know, I can understand that maybe, you know, if you have these things for different assignments, perhaps, I don't know. But that's how you do it, is if you want to point to a register dynamically using the value of another register, So say you have like a counter or something, say R3 is your counter and you have like a bunch of other registers and you want to like sweep across it or something. This is what you would use, right? So if you wanted to sweep across this whole thing, I would probably put register 3 and register 8 first, and then start from 1. Have R3 equal to 1, so that when you do this command, it'll say, okay, go for R1, increment it again, goes to R2, and so on and so forth. You just keep incrementing it till you get to 7, and maybe if you want to self-reference it, probably freak the hell out, but yeah. Okay, so what we're going to do, so what this is going to do is it's going to return 5 steel and return that into R2 right there. And we're not going to get into the SIMD commands just yet, but I'm going to just bulk up M1 because it's only got 3 signals, as dysfunctional as they appear to be. So we can do a quick little loop, and so what I'll do is use X, U, and I, which unifies 2 arguments, 2 memory registers. It takes all the signals in M1 and M2, and then it merges them together and then places it into your destination, which in this case is going to be M1, because I just want to just bulk the thing up with what's in here. So you have 7 signals total. Memory doesn't mean shit anymore, does it? When it comes into position. I have no idea what the hell's going on here. So anyways, just going to run a little loop, and what's going to happen is it's going to move into R3, what register 3 is pointing to. So I'm going to just start from here, and then it's just going to increment it, and it's just going to keep on branching here. So what I'll do is I'll just basically just iterate through here. So it'll be like D, E, so on and so forth. They'll just keep on appearing in here. So this is kind of just like a little loop test or whatever to say like, okay, if you want to act on something in here, and if you want to actually operate on your stuff in memory like you properly should by first moving into your registers and then acting on it and then pushing it back in, this is a way to quick loop through things. So you can push something in, do a calculation, then increment your register to go to the next thing, and then perform another calculation on it again on the next signal. So this is what this would be for. So I go for D, increment it to 2. Now it goes to memory cell 2. All right, pushes in E now, and then just increment it again. So it's now targeting 3. Now I'll just go back, branch. So what I'm saying here is branch if less than, if it's less than 8 values. So I have 7 values, but it's going to be less. All it's going to do is just push in a empty signal toward the end here. But yeah, I'm saying that if it's less than 8, then just keep on doing this stuff. Just keep on incrementing. Okay, so now I'm just going to go and go through that, go through this, and just so on and so forth, in the order that it damn well should. Oh, that's the reason why I did that is because I guess after it's done branching, it executes the next instruction. Let me just BKR BKG like 40 or something, just so it sets. There we go. Okay, so yeah, apparently it doesn't push the last instruction. Doesn't push an empty thing in here when it's at 8. Or maybe it was at 8 and it just said, okay, stop now. I don't know. Okay, so that is the memory tutorial. Caveat emptor. Jesus Christ. That was weird. So yeah, just be aware that ordering is still kind of borked for some reason. Beware of what goes on here. So you're going to have to be careful with the exact ordering that you put stuff in. If whatever you're doing depends on ordering, do be careful with it. Jesus Christ, that's weird. Okay, well, I hope this helps shed some light on things. I'm going to report this to the Discord and let the developer know. And yeah, but at least if you're not concerned with ordering, it does still work. But yeah, just be careful with mixing your memory and register addresses. Never mix those together with a computation first. If you want to do calculations with this stuff, first move it. If you're doing calculations with an individual memory unit, just push it into a register and then play around with it and then push it back into the memory. Do that. If you want to do parallel commands across memory channels, if you want to do operations, if you want to do all this stuff in parallel or whatever, if you want to say add, multiply, divide, multiple signals all at the same time, that will be under the SIMD tutorial. But first I'm going to be doing the external, excuse me, control signals and other stuff that you can do with external signals that we'll be getting into soon. Maybe little hybrid loops and stuff. Yeah, so I'll be doing this kind of stuff in the next tutorial. So I'll be showing you how to optimize your kind of looping functions and stuff. I'm actually going to have the multiplexer is going to be in the next video. This is just going to be a independent example video. I'm going to do this one next, so that if anybody wants to just quick go to it, they can find it directly on the list and copy from it. Also remember, I'll link down in the description below all the different blueprints that you can find on factorioprints.com. So I'll put a link to the user page that I have for all these different blueprints, and that way you can import them and play with them to your heart's desire, and that way you could use these as kind of like little templates to get started with fCPU. Alright, so thank you for watching, and hopefully we have better luck next time. Jesus. Yep. Alright, take care.